हेलो एवरीवन, वेलकम बैक अगेन माय यूट्यूब चैनल अर्थ एकेडमी। क्लाइमेटोलॉजी के सीरीज में आज हम लोग वर्टिकल स्ट्रक्चर ऑफ एटमॉस्फेयर के बारे में स्टडी करेंगे। हमारा टॉपिक है वर्टिकल स्ट्रक्चर ऑफ द एटमॉस्फेयर। एटमॉस्फेयर का वर्टिकल स्ट्रक्चर के बारे में। ओके, इसको हम टू टाइप से पढ़ते हैं। पहला, ऑन द बेसिस ऑफ ऑन द बेसिस ऑफ टेम्परेचर। दूसरा, on the basis of chemical composition. On the basis of chemical composition. ओके, ऑन द बेसिस ऑफ टेम्परेचर इसको हम 5 लेवल डिवाइड करते हैं। मतलब एटमॉस्फेयर will be divided into 5 layers. Okay, and on the basis of chemical composition we divide the atmosphere into 2 layers. Okay, then the name of these 5 layers are, in which first one is troposphere. Okay, next a stratosphere. Next, mesosphere. Next, thermosphere. And last, exosphere. Okay, and on the basis of the chemical composition, the atmosphere divided into the 2 layers, which are homosphere and heterosphere. Okay, if we focus on the temperature variation, then we find out that then we find out that in troposphere the temperature will be decreases with increase the altitude. It means that if you go upward, then we get the temperature will be decreases. In the stratosphere, we find out that the temperature will be increases. In mesosphere, the temperature will be decreases. In thermosphere, temperature again increases. In exosphere, the temperature will be decreases. Okay. Most important point is here noted that the most important point is here noted that in the mesosphere we get the much less temperature. We get the much least temperature, या less temperature at 80 किलोमीटर। 80 किलोमीटर पर हम सबसे कम क्या करते हैं, टेम्परेचर पाते हैं। एंड इन जोन ऑफ द थर्मोस्फेयर highest temperature we get. Highest temperature we get. Okay, then we study one by one. Then the topic is troposphere. Okay, point one, with the altitude, the temperature will be decreases. Okay, means decrease in temperature, decrease in temperature with latitude. Okay, so it's also comes as a lapse rate. Lapse rate we study in previous class is that the lapse rate is defined the how the temperature will be decreases, how the temperature will be vary with height. We go upward to the earth surface, then we get the variation in the temperature. It means that if we go upward to the earth surface, then we get the temperature will be decreases, then how its pattern, how its rate we known as the lapse rate. In the troposphere the temperature uh, will be decreases with latitude. Okay, next point, the height average जो हाइट होता है, the average height of troposphere at equator is 16 kilometer and at pole 6 kilometer. It means that this is earth, this is our atmosphere. Maximum range, this is our pole and equator. The maximum range of the troposphere along the equator will be 16 kilometer or along the pole will be 6 kilometer. Okay, now the warm surface temperature, it show it show warm surface temperature and very high thermal mixing. Okay, there are two key factors is that in troposphere the warm surface temperature will be we get and we get very high mixing, thermal mixing. Okay, the troposphere, the tropospheric temperature at equator, okay, or at pole. We get if we relate the temperature variation at equator at pole, we find out that the equatorial temperature is lowest as compared to the polar temperature. We get relation is that the equatorial temperature equatorial temperature is lowest as compared to the polar temperature. Okay, it means that tropospheric temperature we correlate at the polar at the equator, then we find out the relation between them is that key at or temperature variation is that it, temperature equatorial temperature is the lower as compared to the polar temperature. Okay, the temperature variation we get the temperature condition we get variable like that season to season the tropospheric temperature will be vary. Okay, example it means that tropospheric temperature in the troposphere the temperature vary season to season. It means that in summer or in winter. In summer, high temperature. In winter, high, less as compared to summer. Okay, means overall we get in summer in tropospheric range we get the highest temperature as compared to the winter. Winter also show the high, but its temperature is not more access as compared to the summer. Okay, now troposphere is the layer where all the important weather phenomena occur. Means if this is a zone of the troposphere, if it is a zone of the troposphere, we get all important weather phenomena. All important weather phenomena will be occur here. Okay, here. Okay, if we take example like that, which type of weathering phenomena, just like a cloud formation, cloud formation means all cloud formation will form in the range of the troposphere. Precipitation, okay, a storm activity, violent storm, storm activity. So all weathering phenomena will happen in this range. So it is also known as it also known as weather sphere. Weather sphere. It means that troposphere is also known as the weather sphere. Okay. Now means we focus on the important point is that in the range of troposphere we get the vertical maxing of air. mixing of air. Okay, due to the vertical mixing, season to season, we get the seasonal variation in the temperature. Okay, we get another important point is that equatorial temperature is less than the polar temperature. All weathering phenomena happen here. Okay, now next is stratosphere, and if we take the layer of the troposphere and a stratosphere, this is separated by a layer which is known as tropopause. Tropopause. Okay, means the tropopause is the range is the layer which divide the two zone, which is troposphere and the stratosphere. Now we study about the troposphere. The range of a stratosphere is the range of troposphere is also vary at equator. We also study that at equator we get the range of the troposphere is 16 kilometer, and at the pole we get the range of the troposphere is nearly at average is 6 kilometer. Okay. Now we focus on the tropopause. Tropopause. The thickness of the tropopause is 1.5 kilometer. Is 1.5 kilometer. Okay. Below the troposphere, sorry, below the tropopause, we get the air mixing properties. Vertical mixing of air happened in the troposphere, and in the tropopause, where we get stop any type of the vertical mixing. Okay, it is the zone. Tropopause is the zone where the vertical, where the mixing stop. Okay, means why the mixing is stopped, because the vertical mixing is in the air. ठीक है? Okay, we get the vertical mixing is in here due to this. So we get in troposphere the temperature will be decreased with the latitude due to the vertical mixing of the air phenomena. But here the vertical mixing phenomena will be end due to this no decrease in temperature, means the process of decrease in temperature will be stopped. Okay, due to this the lapse rate is zero, because lapse rate defines the decrease in temperature with height, but the range between the 1.5 kilometer, there is no vertical mixing of air. Due to this decrease in temperature with height is stop is zero. It means that lapse rate is zero. Okay, so we also say that with the normal lapse rate is zero. Okay, here there is no vertical mixing profile. Here there is no vertical mixing profile, so it's act like a isothermal. Isothermal because iso means same thermal in temperature. It means that between this layer, between this depth, we get no vertical mixing. Due to this, it's act like a isothermal. Okay. Here we mainly focus on the a concept is like that the vertical mixing of air. Okay. Now to understand the vertical mixing of air, we focus on the important topic is like, for example, this is earth surface, this is earth surface. Okay. This is the atmosphere. Okay. It is near to the earth. It is a uh, for distance to the earth. Okay. Here we know that gravity applied, earth applied a force which is known as the gravitational force. Okay. It means that from upward to downward, when we go from upward to high latitude to low latitude, or high point to the surface, we find out that gravity impact, the gravitational impact or gravity impact increases. Okay. due to this due to this, it show low density, or we also know that if you go upward from the earth surface, we density of the material is decreases because the gravitational impact from the earth surface will decreases. Okay. This zone is due to the gravitational pull. The material is highly concentrated here. Due to this, it show the high density, or this range is show the low density. Okay. So if we go from surface to the upward, density first density decreases due to decrease in decrease in gravitational effect or gravity impact. Okay. So if the density will be decreases, it means that the temperature also decreases. So temperature decreases in troposphere. Troposphere. Okay. Now we focus on the concept of the vertical mixing of the air. Vertical mixing of air. Now let's suppose this is our earth surface. Okay. This is the zone A and this is the zone B. And solar radiation come to the Earth's surface. Solar radiation. Okay. When solar radiation strike to the Earth's surface, then the zone A strike to the heat energy. Okay. When heat energy of zone A collide with the dense zone A, when heat energy or solar energy collide with collide with dense zone A. Okay. When heat energy collide with the dense zone A, we know that near the Earth surface we get the dense इसकी density, it's so high density as compared to A, B so less density. Okay. Now when heat energy collide with the dense zone A, then particle its the particle energy will increases because heat energy will strike due to this the variation, sorry, the vibration between the particles of this zone will start increases. It means that it's so the rate of vibration will be increases. Due to this, if the vibration of the between the particles or in the particles will be increases, due to this its kinetic energy increases. Due to the kinetic energy increases, its these particles will be start to move from high dense zone to the low dense zone. Okay, this start to move from high dense zone to this low dense zone because he wants to emit our energy or because he gain extra energy from the solar radiation. Due to this, it get the extra energy from the solar radiation. The particles increase its own kinetic energy, and due to this, it's go from the low dense material, low dense, high dense to the low dense. Okay. Now, when high dense material move towards the B, when high dense material move towards the B, then the zone of A will be the zone of A will be will show gap or free space. Okay. Then to fill up the this area, to fill up the this area, this zone A, particle of B will move downward, fall downward towards the A. Focus. Initial case, it show the dense, it show the low dense. It show high dense, it show the low dense. Okay. Due to high dense or gravitational pull, it's lie or near the Earth surface, and due to the low dense, E lie above the zone A. But When solar radiation fall near the Earth's surface, its kinetic energy increases. Due to this, its move upward and its zone is create like a void. To fill this zone, the particles of V is fall downward to the A. And this process and this phenomena, this phenomenon, which type of phenomenon? Air move A to B and B to A. Air move A to B and B to A is known as the vertical mixing of or called air turns over and called air turns over. Okay, now it is the whole concept of the vertical mixing of the air. Now, lapse rate. We recall the concept of the lapse rate. Okay, lapse rate is mean that the decrease in temperature with height. Okay, its rate show 6.5 kilometer, sorry, degree Celsius per kilometer. If we go upward, it's a variable. First means that we also study that lapse rate we study in the two terms. First is the dry adiabatic lapse rate or uh, wet adiabatic lapse rate. But here is the average is that the lapse rate it's a normal lapse rate or environmental lapse rate. Its value is like that the 6.5 kilometer per degree Celsius per kilometer. It's a variable, but we get we as an average we find out that its value is very location to location. Okay, so its value is given. We study about the lapse rate in previous lecture too much detail. Okay, now now we focus on that. We study on that. We study that the temperature in troposphere equator show less temperature as as compared to the pole. Why? Okay, equator at the equator, the vertical mixing of air is more. Okay, okay, okay. Now, the at the equator, the vertical mixing of air is more because we know that we know that equator show high temperature. Equator show equator has high temperature. Okay, if equator has high temperature because the solar radiation, the amount of solar radiation at the equator is more. At equator, the solar radiation is come perpendicular to the surface. So, if we get the solar radiation perpendicular to the surface, it means that the all radiation, if 100% radiation will come after passing through the atmosphere, we get it's a 100% from here, not here. From here if you assume that the 100% solar radiation will become, then its strike to the earth surface is perpendicular, means all no any amount of energy will be passed out anywhere. It's strike to the earth surface totally. It's mean that at high temperature, equator show the high temperature. Due to the high temperature, more kinetic energy will be increases of the particles due to the high vertical mixing. So as compared to the pole, because at the pole the sunlight strike to its and make some angle. Due to this, if we show the components, some amount strike to the pole and some amount will reflect back. Okay, so the vertical mixing process at the equator is more as compared to the vertical mixing of the process. Sorry, vertical mixing of the of air is more at equator as compared to the pole. Now, the process, the phenomena of the vertical mixing, the phenomena of the vertical mixing occur. It's a simple. The range, the range, it's defined. It means that the range of the phenomena of the vertical mixing is defined the range of the troposphere. ट्रोपोस्फेयर जोन मतलब सिंपल से ही है कि अगर जहां तक जिस रेंज तक वर्टिकल मिक्सिंग हो रहा है, यहां से लेकर अगर यहां तक हो रहा है, इट्स अ रेंज ऑफ द ट्रॉपिकल ट्रोपोस्फेयर जोन. इफ इट्स अ रेंज इज हेयर, यहां से लेकर यहां तक है, तो ये क्या हो जाएगा आपका, इट्स रेंज ऑफ द वर्टिकल मिक्सिंग इज, यहां से यहां तक है, ये टोटल का टोटल जोन क्या हो जाएगा आपका, ट्रोपोस्फेयर हो जाएगा. मतलब जहां तक वर्टिकल मिक्सिंग हो रहा है वहां तक आपका क्या है, ट्रोपोस्फेयर. The range of the vertical mixing phenomena is defined the range of the troposphere. Okay, now let's suppose this is equator or this is equator. It is equator region. This is polar region. Polar region. Okay. The temperature of upper layer of troposphere, of the temperature of the upper region of the troposphere, we get minus 31 degree Celsius. Okay. At equator, the upper troposphere temperature, troposphere region temperature will be minus 66 degrees Celsius. Okay. Now, it's a variation is, it means that the here polar show minus 31 degrees Celsius, equator show minus 66 degrees Celsius. We also study about that key in zone of the troposphere who equatorial region show the less temperature as compared to the polar region, because it's like here it's minus 66 degrees Celsius or minus 31 degree Celsius. Okay, why this is happen? Now, it's all phenomena occur due to the lapse rate. Focus the main concept of the lapse rate. Like that, at equator, lapse rate variation given 6.5 degrees Celsius per kilometer. Okay, the maximum range of the maximum range of the troposphere at the equator is 16 kilometer. Now, for 1 kilometer, for 1 kilometer, lapse rate show 6.5 degrees Celsius. Now, for 60 kilometer, lapse rate show the temperature is 6.5 into 16. It is equal to 104 degree Celsius. From the rate of the 104 degrees Celsius, the temperature will be decreases. Now, for the polar region, the range of the polar of the troposphere is 6 kilometer. Now, for 6 kilometer, lapse rate is 6.5 multiply 6 equal to 39 degree Celsius. It means along the pole we get the temperature decreases range is 39 degrees Celsius. If we go 6 kilometer above from the Earth's surface along the polar region, we get only decrease in temperature 39 degrees Celsius. But along the equator, we get the temperature decreases with 104 degrees Celsius. So the polar region show more temperature as compared to the equatorial. Okay, then now we stop the lecture here, and tomorrow I will focus on the other zone, just like a stratosphere, mesosphere, and next. Then पढ़ाई करते रहें. All the very best. Thank you.